Good. So you can all hear me. Good. So this is my talk, titled, the talk is titled, Why is the RAM Gone? But when I looked up my quote yesterday, I discovered that actually the title should be, But why is the RAM gone? Because there is Captain Jack Sparrow, the inspiration of the quote. So a bit of background. So you've written a program, you want to analyse it somehow, for some reason. Maybe the program doesn't work. If it doesn't work, you might run some unit tests on it. You might run Perl-D or something else. Generally, these are all called debugging tools. These are, we've got a bug, we want to find the bug. Alternatively, you might have the problem that your program works, but it's just kind of slow, it's big, it uses too much memory, there's something, it basically works, but it's not right, so we need to tweak it a bit more. So in order to understand why, we need to run a different kind of tool called a profiler. And there are many different kinds of profilers. So traditional profilers you might already know, if your program is using too much CPU, you've got things like dprof, nytprof, and apparently I can't check my mail, that's very important. No, go. So yes, we might be some of these tools. If the program uses too much network or I/O, we might run strace, TCP dump, Wireshark, that kind of thing. All these things record a journal of activity that the program does over time. Other types of tools that we might have, memory usage. If the program uses too much memory, might run Devel size on some things, find out why they're big. Might run Devel size me, which Tim will be talking about later. So I will stop on there. Or we could run Devel mat, the memory analysis tool, which is a thing that I've been writing lately, which I will talk about. And all of these tools are quite different from the sort of CPU or performance profilers in that what they do is they record a snapshot of the whole process state, so that you can look at all of the contents of the memory at that moment in time. So Devel mat, how does that work? Well, it sort of comes in two parts. There's the dumper part, and that writes the entire contents of the process to a file. So everything that was in memory gets splattered out to a file, and that's sort of a very tiny, quick. It's got to be as quick as possible because you might be running it in the middle of some kind of interactive process, possibly web serving, possibly whatever it is you want to do. You want to add as quick as possible. So all it does is writes a whole ton of memory onto a disk. And then later on, in possibly a different machine, possibly a different Perl version, possibly wherever you like, later, you can then analyze that file with the actual Devel mat itself. So specifically Devel mat dumper. What it does is it writes an atomic snapshot of the whole process. It obviously can't write actually atomically because it's going to take time to do, but it's a single function, and so while it's running, with any luck, nothing else is happening within Perl while it's doing so. So it's just got access for a moment to just go through all of the memory, write down everything. So it writes down every SV on the heap, which is basically all of your allocated data, everything where all that is. Every SV that's on the data stack, because there's multiple stacks in Perl. There's about 6 of them or something too. Every entry on what's called the context stack, which is the data structure that the caller function uses to work out which functions we're in and so on. So we can find out everything that was in memory at the time and what the program is in the middle of doing. And finally, all of what we call the root pointers, which are basically every pointer that is part of the internal structure of the interpreter, so that it knows where to start looking for things. These are called roots. So we can dump this thing at various times. First of all, we can just call its dump function. That's the most easy way, the direct way to do it. But obviously that might be a bit inconvenient depending on the kind of debugging task you're doing. You can tell it just to dump automatically at any time. That's quite useful. I'll show you that one. And also, I've hooked it onto a couple of signals that might be useful. The SigAbort is your standard debugging signal to say, alright, everything's all gone wrong, drop me out on the debugger or something. And you can hook Devel Mac in there to say, while you're on the way to the debugger, just dump the memory state, because that's useful. SigQuit I picked because most people tend not to use SigQuit, but it's quite useful because control / usually sends a SigQuit, and hardly anybody ever looks at that normally, so I just thought, hey, that's kind of useful, SigQuit. So I'm going to show you. So I have here. Oh, sorry, there. Nice little tiny program. Use Devel Net dumper. Set up a memory state, and then tell it to dump to a file. So that's all it's going to do. So this obviously isn't a real debugging example, but this is just kind of designed to show what you do. Do you run it? How do you have fun? So let's try and analyze it. So a nice little simple thing we can do is net count on the dump file. Yeah. And we can see, we have 118 arrays, 91 codes, 172 globs, you know, all this kind of stuff. Yeah, we've got some data, very exciting. What else can we do? We could dump the symbol table. And, very good. Well spotted. Yes, so we have a bunch of symbols. And that's the whole symbol table from the program at the time we ran it. Very exciting. But the most excitingly interesting one, which you'll probably spend most of the time running, is the GTK Explorer. So here we have it. So what we have here is a huge long list of all the SVs in a particular order, with some details about them. And we can go off and explore them. So for example, we can start at what's called the default stash, which is basically the root of the symbol table. And we find, hey, here's the default stash. Oh, my window is too wide. This is awkward. The monitor is too narrow. This is very unfortunate. So we have a bunch of symbols in here, and we can go off and do things like, I don't know, IO space. And that has a hash over here. Oh, there's a thing called handle, and we can go in here, and we can find, oh, there's some more things here. We can kind of explore the internals of the process, and a lot of this is internals. But there's bits of user data here and there. So for example, the code we were looking at, let's go find it. So we had our little array here that had a string and a number and a little hash in it. So let's go off and see where they were. So here we have the main code. This is going to be very annoying. Oh, no. So we have a whole bunch of stuff in the main code, and oh, it has a lexical called foo. How exciting! There's a reference to an array, and because in the Perl internals you get these little references all over the place, the tool is being just a little bit helpful and saying, well, actually, rather than make you go through the ref to find it, I'll just say, well, you can see the array directly. So here we have our array, and it seems to have 3 elements in it, because the last one is a hash ref, so I've got it twice. So we can see, oh, there's our string, exciting. Here's our number, and here's our hash, which has 2 values in it. That's all very exciting. That's not particularly interesting because that's not a very exciting program. So, what is that? So let's have a new program now. Slightly more exciting one with a real bug in it. So here's our little program, and we're going to create a memory cycle, and that's bad to bug because cycles don't get corrected. So if we run this one, and this time I'm going to tell it to dump at end. And so it's written another file. So if we go and explore this one, So notice that the program doesn't actually have to have develmat in it. We just tell develmat dumper, by the way, dump it at the end time. And it does that automatically for us. So here we are, we load this. And tell the reachability tool to run. And that goes off and it annotates every SV and it says how these are reachable. So we have a lot of these green ones that say, well, these are reachable by user data. And there's a few other ones here and there and there. I'll talk about that later. But what we can do is, if we go into the main code again, we find that there is a lexical called cycle, and it doesn't have anything in it because it was at the end, and all the code was did. But if we sort these by their reachability, we find that what we have in the middle here is a whole bunch of unreachable ones. And if we look in here somewhere, we will find that there is an array. Here it is. So it's kind of hard to see at the moment because this is a fairly raw analysis of the program. But what we have here is an array that has a reference to itself and nothing else. Nothing else actually referring to this array other than itself. So this is our cycle. This is our bug. But that's kind of a fairly boring example again. So. Oh, go away! No, that one there. Let's do that again anyway. Right. So, so just as a sort of a summary of what we've seen here. So we have Devel map that loads the file. It allows the tools to be applied. And we saw there was one tool at the moment called Reachability. The Explorer. So all of the interesting analysis is in the things called the tools, and these are sort of a bit like plugins. So what they can do is they can analyze all of the SV data. They can add methods to the actual internals of the code to sort of add more stuff. And most importantly, they can extend the Explorer, which I showed you. I'll show you more in a moment. So of the tools, we've seen count already. Count, kind of fairly obviously, it counts the types of SVs. Pretty little output that looks like that. We've got the tool called inrefs, which the GTK Explorer uses automatically to provide one of the other columns there. It counts the incoming references to a thing. So as well as so from every SV we see what it can reach and what other things can reach it, because a lot of useful analysis comes from that. It also allows this method which I call identify. Creates an output. It's a bit like that. Looks very similar to Devel find ref, but obviously on the dump file. And there's benefits of internals that use that as well. And then finally the reachability tool, which is the only other tool I've got at the moment, which determines which SVs are reachable and how they're reachable. It can help you identify leaking scalars because they're the ones that exist but are unreachable. And it's the one that adds this little column at the side here. The icons aren't very clear at the moment, but those sort of indicate things that are user data, green. The yellow S's are things that are to do with the symbol table, so they're kind of automatically reachable. The P's are very exciting bits of internals, pad lists, and it turns out there's a lot of those around, and they're not actually very exciting for most purposes, but you kind of have to find them. So now on to a real example. So this is a real example that I actually ran into last week. So I have this program for talking to Amazon S3, and I like to talk later, I'll explain more about that program. Basically, I was running this program, sending this huge file into it through a pipe, and it was running, and it was sitting away, and it was doing things for a little while, and all of a sudden it dies out of memory. Oh no, this is great, because I now have an example for my talk. So I ran it again with Develmat dumper, and it ran out of memory, and because out of memory still invokes all the end blocks, this is quite useful. So it dumps the file. So I thought, well, what's in that file? Oops. So I have here the very file. Explore GTK S3. And this one takes a little while to load because it's big. So I'll get there in a moment. Well, one of the first attempts at this, I had a huge file that took my laptop 3 hours to load. Which is why I had the progress counter at the bottom, because I wasn't doing anything at all, and then I discovered, oh yes, it is doing something. Oh, it's just got to 1%. This is going to take a while. But this one is a little bit quicker now. So first of all, we see we have a huge amount of data in the file down here. I should probably put some commas in there, because that's 400. That's nearly 500 meg there. One of the reasons I ran into this bug was that it's a small memory VM, and it ran out of memory a bit too quickly. And so I loaded this thing, and the first thing I did was sort by size, because that's a fairly obvious thing to do. And so we have a whole ton of little things at the top here, things slightly bigger, slightly bigger, bang, and all of a sudden at the bottom, a load of huge things that are all just a little bit over 100 meg. And the reason for that is that we're doing this upload to S3 in 100 meg chunks of the file. For again reasons I'll explain later. But so what I did was I had a quick look around these huge things to see what they were. So here we have a huge great PV. This is just a string that's got a whole ton of data, blah blah blah, and it happens to be an element of an array. Well, that's not exciting. What have we got next? Now this one here, as it turns out, is the reason for the bug. This one here is a huge great PV, it's 100 meg big, and it also happens to be $@ in the interpreter. Now $@ is the current exception. So I thought, oh, this is a bit unusual. Why is the current exception 100 meg big? Why is it 100 meg big? And doesn't actually have any data in it, but it's 100 meg big, but it doesn't have a PV yet. This is slightly odd. So the next one that we find is we find a string. And the string is the complaint, oh, I don't know what to do with 100 meg string. And so I thought, well, this is even stranger. In fact, I remember where that string comes from. I'm sure what to do with. I remember where that is in the code. So what this string is, by following the inrefs, we go back, and we find that this string is the value, is a member of an array, and that array is the member failure of a future. Oh! Well, it turns out that if you have a future and it fails, and it was a nested future, so another future is going to fail. And another future is going to fail, another future. So you have this whole tree of futures that are all going to fail with the same message by copying the string, which is 100 meg. And so it turned out, actually, yeah, that was the bug. And so the bug was that I was trying to print the value of the content that I didn't know what to do with. And so I changed the code to, if the thing was more than about 100 bytes long, I just print, oh, and the content was n bytes long, and that solved the bug. So that was a very easy one to find because of this tool. So, just to sort of summarise. Oh, I can't see. What's this? So yeah, there are a few outstanding issues in the thing at the moment. There's a lot of what I call orphan SVs, which are SVs that I know exist in the Perl interpreter, but I haven't found a reference to them. And some of them are just kind of internals with weird pointers or bits of excess. They're kind of a bit noisy. I don't know what to do about them. There's also a number of dangling pointers at the moment, where I find pointers to SVs that I haven't found, but I know they're real pointers, and so I don't know where they come from. It's a bit annoying. And I've got a lot more ideas for more tools to write. So what I want to have is a cycle finder, things that can automatically find memory cycles. I want to measure what I call the retained size of objects, which is the size of the object plus the things that it is holding a reference to. Because often you'll find you've got an object itself that's quite small, but it's hanging on to lots of references to other bigger things, and it's useful to know what that one is. I want to be able to find SVs by their content. They say, hey, I know there's a string around with this name in it somewhere, and please find it for me. I also want to do some more UI integration, more fancy UI there. I want to do some SV filtering, because obviously that's a huge list and it's very hard to navigate. And finally, I want to do more interesting UI at all. So I want to add other panes to the UI. I want to have a symbol table tree, that'd be quite useful. I want to add a view of the caller stack, because currently there's no visibility of the caller stack on the UI. And I want to do what I call the neighborhood graph, which will be where you'll take an SV and you'll say, okay, show me it, and then show me the things that it immediately references and references it to either side, and then sort of add a few more layers and build those up. So that'll be exciting. And Tom Molesworth, I thought he was here today, but he's actually written a ticket UI for it rather than a GTK one, which is kind of useful if you're running it on a remote server in the middle of nowhere and all you've got is SSH. Although you can just pull the file from, I don't know, it's kind of. And that's the end. So, questions maybe? Oh, there's some. I don't know. We'll start at the front.
What would be a useful feature is if you've got two dumps from two different programs and you can compare them.
Yes, yes. So the comment, if anybody didn't hear, was being able to take two dumps and compare them. Yeah, I have thought about that. It starts to get tricky because all you have is the memory address of things, and so sometimes you can't tell, well, is this really the same thing, or has it been deleted and a different one put in the same place? And it's kind of useful to a point. It can sort of tell you when things are the same or different, but because it's only two snapshots, you haven't got the history in between, and it can sometimes be a little tricky to work out what's happened. But yeah, I'm planning to do some analysis on that and see how useful it might be. Yep.
Thank you, that looks really useful. I can imagine wanting to analyse the PMAP files using the GTK tool on a different machine from the machine that generated them.
Yes.
So I assume they're portable?
Oh, absolutely, yes. I mean, that was very much in the I should point that out. Yes, the one the S3 one was that was running on a small VM somewhere, running Perl 514. And I pulled the dump file onto my laptop, which is running 518, different CPU architecture, everything. Yeah, because the header in the dump file, it writes down the Perl version, which sometimes helps with the analysis, because obviously there's a lot of very specific Perl version internals, and whether or not it's running threads, and whether or not it's got long doubles, and there's so many. Oh yes, shut up about my mail, go away. And so yeah, there's a lot of internal details, and you very much need to know what machine it was dumped on. But that's all annotated in the file so that you can put it onto a different machine and analyze it. Yeah. Was that it? No other questions. Stunned silence. Right. Oh, Tim.
How well does it scale to big applications?
How well does it scale? Yeah, so as I said, the first version, when I first wrote it, I was trying to hunt a bug in some code of mine, and dumping the file took about 3 seconds, and then loading it again took about 3 hours. Part of the reason for that is that every SV that you've written into the file, when we load it into the analyzer, because the analyzer is all written in Perl, it's got to have an SV to represent that. And then because that object is actually a hash, it then needs a whole load more SVs for all the members. So everything you load has a sort of a blow-up factor of about 9 times. And to load that file on my laptop, I had to add another swap LV on the disk and close every program and adjust the X server so that the X server wouldn't get killed, and yeah, it was awful. So that needs some work.
Too massive to find out where it was going.
No, because that was going even further, you see. I mean, I knew it was going to be big. It's just that it's going to be big because it's Perl. So yeah, a lot of internals need to be writing in XS and to be a lot faster, a lot smaller. Oh, that's one.
How easy is it to write a tool if I want to write one?
Yes, quite easy. So I've actually got, I haven't got a browser open at the moment, but there's actually there's actually a pod file in the distribution called Devel tool that explains the API for how to write a tool. So, yeah, no, I'm planning to write a few and stick them on CPAN as kind of examples of here are some more tools. That's the whole point. And then they just get loaded into the UI, and you can just do whatever with them. Well, I think we're probably about on time there, so I'll call it there. Thank you.